Welcome. The purpose of this video is to go over some of the homework problems that you had last night. In this worksheet, compound inequalities, the majority of them worked out exactly as we expect them to work out. There's a few things that I would like to note and point out. And number 2, when we use the word inclusive, it's just a root form of include. So both of the 25 and the 30 should be shaded in. Let's take a look at some other ones that worked out just a little bit differently than we would expect them to. In number 5, we have an or situation. We would expect to have two inequalities facing opposite directions, kind of like oars on a rowboat. But in this situation, we don't. We get all real numbers as a solution. In number 6, we would expect, again, an or situation which would have two endpoints and the graphs pointing outward. But instead, we just get one inequality with one graph as our solution, or one shaded in part of the number line as our solution. We're going to take a look at both of these problems. In number 5, when we're working through number 5, we go ahead and solve each inequality separately. So we're going to add 1 to both sides, and we get 6b is less than or equal to 42. We divide by 6, and we get b is less than or equal to 7. Or, in the other case, we're going to go ahead and add 1, and we get 2b is greater than or equal to, we're going to subtract 1 and get 10. And then we're going to go ahead and divide by 2, and we get b is greater than or equal to 5. This seems like it's a fine inequality. We've got two different inequalities, but when we go to graph these two inequalities, we graph 5, the smaller number, then 7, and we're going to go ahead and I'm going to start with the smaller one. B is greater than or equal to 5. We take 5, we fill it in, and then we start shading all the numbers greater. But this is an or situation, so this should kind of raise a red flag that we're passing one of our other solutions. We go ahead and we pass it, and then for the next one we have b is less than or equal to 7. We take 7, and we shade all the ones less. In a situation with an or, we take the combination of the two solutions. In an or situation, only one of the inequalities has to be true in order for it to be a solution. So in this case, we take the whole number line, or we get all real numbers as our solution. In number 6, and again, let me scroll up so you can see the answers above. In number 6, we've got two inequalities with an or situation, and we solve both inequalities. For this first part, we're going to subtract 5 on both sides. We're left with negative m is less than negative 1. Then we divide by a negative, and we get m is greater than 1. Remember, when you divide by a negative, you flip that symbol. Then we have over here on the other situation, 7m is greater than 35. We divide both sides by 7, and we get m is greater than 5. All right, we go ahead and graph this situation. We'll draw our number line, put 1 and 5 on the number line. For the first inequality, m is greater than 1, we put an open circle on 1, and then we go ahead and start shading the numbers greater. This is an or situation, so we can go ahead and pass 5 as a solution. Then for the next one, where it says m is greater than 5, again we put an open circle on 5 and we continue shading. This does not negate 5 as a solution for the first inequality. 5 is still a solution for the part where it says m is greater than 1, so we don't erase this or unhighlight it. It continues to be shaded in. If you'll notice in the answer above, they don't make a big deal about 5. They don't have an open circle on 5. There's nothing going crazy with number 5. We don't erase number 5. It's still part of the solution. So we just have one inequality and one graph and one inequality. Because it's an or, we take what they have in common, the union or the combination of the two together. In number 11, this is a unique and situation because there's the variable y in more than one place or in more than one part of the inequality. Although there are many different methods for solving this, probably the most basic way to solve is to split up this and inequality into two inequalities. We're going to take the first part, and then we're going to go ahead and take the second part. Notice that that middle part comes with the second inequality, with the word and in between. So for the first part, we have 4 is less than or equal to y plus 2. For the second part, we're going to take y plus 2 is less than or equal to negative 3 parenthesis y minus 2 plus 24. And remember, the word and is in between here. Okay, we solve this first inequality, very nice basic inequality. We're going to subtract 2, and we get 2 is less than or equal to y. And we're going to solve the other inequality. In this case, we're going to distribute the negative 3, so we get y plus 2 is less than or equal to negative 3y plus 6 plus 24. We're going to add the 3y to the other side, getting 4y. We're going to subtract the 2y from 30, the combination of those two. So 4y is less than or equal to 28. Divide by 4, y is less than or equal to 7. And there's an and here. Since there's an and, we like to condense these two inequalities. So we like to have y in the middle, the smaller number on the left, the larger number on the right, and then we follow the symbols. Y is less than or equal to 7, and at the same time, y is greater than, or 2 is less than or equal to y. This situation works. We've got a situation where we go from smallest to largest. We have two less than symbols. It reminds us of and it reminds us of a sandwich. Alright, so scrolling down to check some of your answers. If you'd like to take a closer look at this, the answers will be displayed on Blackboard, and you can take a closer look at some of your solutions and come with questions prepared next class. And if you notice that number 11, they have between 2 and 7 right here. This concludes the end of going over, oh, I apologize, it does not include, I apologize. I wanted to go over number 31 before we concluded. We'll go over 31 and then we'll conclude this video of going over the homework. For number 31, as you've already done this assignment, you've read the problem more than one time. You should write down all critical information. Writing down nothing is no good. Alright, it says that the absorbency of a certain towel is considered normal if the towel is able to hold between 6 and 8 milliliters. Later on, they give us the variable m, so I'm going to go ahead and write an inequality that says that if a normal towel will hold between 6 and 8 milliliters. Alright, the first checks for the materials result in absorbency measures 6.2 and 7.2. So in essence, we've done two different tests, and we're now going to do a third test. We want to find the average. Okay, so our absorbencies of 6 and 8 milliliters is still going to hold true, but we're going to go ahead and do the first test, which was 6.2, plus the second test, 7.2, plus the third test, m, that's going to be less than 8. We want to find the average, so we're going to divide all of that by 3. This is the inequality that we use to solve to find the last test, what test grade we could have, or a test absorbency we could have. You could treat the same as test grades. If you want to get somewhere between in the B range, then you're going to have that inequality between two values. So in this situation, we're going to go ahead and add 6.2 and 7.2. When we add those two, we get 13.4. Multiply everything by 3, so you have 18 is less than 13.4 plus m less than 24. Apologize, that's squished in. And then you go ahead and solve, and when you do, you get this inequality as your answer. And the last one, number 32, all you have to basically do is graph the three inequalities. They're graphed on the same number line. You can graph them on different number lines, that's fine. The one thing to note is that on number 1, you cannot have a baby of 0 pounds. In fact, even having close to that is probably not appropriate. But you cannot include 0, because that just wouldn't happen. And then the 15, I believe, 15 to 40, this should be an open circle on 40. And then 30 to 80 is both, 85 is both inclusive. Alright, this concludes the video. In the next video, we'll go over the notes on special cases.